Here's one more application regarding compound interest. What will be the rate of interest R needed if you're going to compound annually, which means that N is going to be one time per year, in order to get the investment to double in 15 years? So we are being given that N is 1, T is 15. We are not given a principal or present value, but it doesn't matter. Pick a number if you like, and then double it and put that in for A. Even this, where I'm not picking a number, it's not going to matter because I'm trying to get R alone. And the first thing that I'm going to do, after writing this a little more simply, is that R is in something to the 15th power. So I'm going to isolate that. 1 plus R to the 15th by dividing both sides by P. So whatever number you chose for P, eventually you'd get to this step. Now, to get rid of raising to the 15th power, one approach would be to take the 15th root, which would be the same as raising both sides to the 1/15th power. And then finally, to get R alone, subtract 1 from both sides, which would be the same as adding -1. I'm going to put that into the calculator. So -1 plus 2 to the 1/15th. -1 plus 2 to the 1/15th power. Notice that I'm putting parentheses around that because I have the calculator in the classic printing mode. And converting that to a percent, you would move the decimal place 2 to the right. And since we're supposed to go 3 places after that, sorry, 2 places after that, to the hundredths place, the 9 after the 2 would round that up to 4.73%. Now, some of you might be wondering, wait a minute, this is in a set of problems where we've been largely applying things that we've learned about exponential functions. The reason I dealt with taking the 15th root was because we know what that power is. But what if I took the natural log of both sides? The power rule would let me bring the 15 out in front. And then I could divide both sides by 15. Notice it's only the 2 that we're taking the natural log of there. 15 is not inside of that. We're dividing after taking the natural log. To my mind, we've traded one problem for another. what we were solving for, r, was part of 1 plus r, and that was in the 15th power. Now I've got that 1 plus r inside of a natural log. To get rid of that, I would have to use that as a power for e. Cancel out on the right-hand side, sorry, left-hand side. And then I would have to subtract 1 from both sides, same as adding -1. Let's see what we come up with there on the calculator. Making some noise back there. Not sure what I've got behind me. Oh, coat fell. All right, so what we came up with the first way, when rounded to the nearest hundredth of a percent, was 4.73%. Let's see if we can get the same. -1 plus e to the power of natural log of 2 is being divided by 15. So that natural log of 2, then divide by 15, that's our entire exponent. And it looks like we're getting the same as a decimal. Then when we move it 2 to the right to turn it into a percent, 4.73% that way as well. I think that's taking some extra steps in that second approach. And we took a natural log, we got something isolated, but then we had to get rid of the natural log with its inverse function, raising e to that power on each side. So I think that was probably a tougher route to go.